In concept B, we're going to be focusing on something called colligative properties. This is how a solute affects the properties of a solvent. So when a solute gets dissolved in a solvent, the particles are attracted to the particles of that solvent. This means that the solute is going to affect the properties of the original solvent. Now, these changes are solely determined by the amount of particles of the solute in solution. It doesn't matter directly about the type. So, what are these important effects of adding a solute to a solvent? Well, first off, it lowers the vapor pressure of the solvent. It's going to raise or elevate the boiling point of the solvent, and it's going to lower or depress the freezing point of the solvent. So, how does this happen? Well, here we have plain water, and we have water vapor. However, over on the right, we've now dissolved sugar into the water. Sugar molecules get in the way of evaporation. That means that there's less vapor, so less vapor pressure. It's going to take more energy for that vapor pressure to equal the atmospheric pressure, which, remember, in order to boil, they have to be equal. So because of that, it elevates or raises the boiling point. When freezing, they also get in the way of the solvent particles coming together. They're basically acting as little blocks between the water molecules. The solution has to lose extra energy, go to a lower temperature in order to actually freeze. So again, the more solute that is added, the higher the concentration. It's going to raise or make the boiling point higher, and it's going to lower the freezing point. So you can think of this little picture here. It's going to increase, push up the boiling point, while it decreases or brings down the freezing point. So remember, the change in boiling and melting points depend only on the amount of the solute, not directly on the identity. Solutes can break up into pieces, usually ions, when they dissolve, and because of this, they're going to have a greater impact on the freezing, melting, and boiling points. So one thing I want to point out is, say with just the solvent, we have a liquid that can exist between 10 degrees Celsius and 80 degrees Celsius. When I add a solute to it, I've now increased the boiling point, drop the freezing point, so it remains a liquid at a wider range of temperatures. This is very vital to many of the materials that we use every day, such as why we salt roadways or use antifreeze in our cars. And we'll talk about some more examples in class tomorrow. Now, the next two parts are going to tie right into the number of particles in solution, how that affects the properties. Something called electrolytes, which we mentioned before when we did conductivity. These are substances that produce ions when they dissolve. Since these charges are free to move, these solutions conduct electricity. Now, when ionic substances dissolve, this is one of the types, they're going to dissociate or break apart. Remember, ionic substances have a metal and a nonmetal, metal and a polyatomic ion. It could also have two polyatomic ions. These all break apart and form additional particles. They're ions. Another type of electrolytes are acids. Now, we haven't gotten into acids and bases yet, so I just want you to be able to look at Table K as a list of examples for acids. Now, acids are a polar covalently bonded substance, which we know normally don't break apart. However, acids are an exception. They're going to interact with water, ionize, and create ions in solution. So that's what causes them to act like an electrolyte. Now, non-electrolytes. These do not dissolve into ions in water. They're going to have a smaller or less of an impact on the freezing and boiling points because they do not break up any further. We can't come up with the additional particles, so we have a smaller number of pieces with our non-electrolytes. Since electrolytes come apart and create pieces, their boiling, elevation, and freezing depression is greater than for molecular substances. So again, electrolytes are going to have a bigger effect than are non-electrolytes, which are molecular substances. Okay, so if I put in 3 particles, so I have 3 sugar particles, and I put in 3 formula units of an ionic substance, so I have 1, 2, 3, I can see that I've created 6 particles on the right with only 3 particles on my sugar. So my electrolyte, the salt water, is going to have a greater difference in boiling and freezing points. So let's look at a couple examples. This is usually the hardest part for students, is actually looking at examples and figuring out what's going to have the greatest or least effect. So the first thing you have to think about when you look at a formula is it an electrolyte or a non-electrolyte? Electrolytes, ionic compounds or acids. Non-electrolytes are covalently bonded compounds. So KCl is a metal and a nonmetal. So we do have an electrolyte because it's an ionic compound. and it's going to break up into a positive potassium ion and a negative chlorine ion. So that gives me 2 particles. Now this next formula is covalently bonded, so it's a non-electrolyte. Usually when you see a carbon out in front, that gives you a hint, especially with the questions we'll deal with, that you have a non-electrolyte. So that means then that we're going to stick with only 1 particle for every one that we get. Calcium fluoride, it is ionic, so we have metal and a non-metal. This is an electrolyte. It's going to break up into 1 calcium ion and 2 fluorine ions. That means we get 3 particles that it breaks up into. So which has the greatest and least effect? The one with the most amount of particles is going to have the greatest effect. The one with the least amount of particles is going to have the least effect. And we'll practice this a lot more tomorrow so you get comfortable with doing so. So again, the more particles that a solute breaks up into, the higher the boiling point and the lower the freezing points. Okay, and that's it. So we'll go over this a lot tomorrow and be practicing this throughout the unit. And one thing left to leave you with after that is, why did the white bear dissolve in water?